In this video, we want to learn how we can multiply or divide rational expressions. Multiplying rational expressions like this example is really easy. Simply you have to multiply numerator by numerator and denominator by denominator. But before multiplying numerator by numerator or denominator by denominator, first we try to simplify the rational expressions. Then after simplification, we start multiplying numerator by numerator and denominator by denominator. So let us start this example. We have 6x in numerator. In denominator, we have x to the 2 minus 9. We know that we can factor x to the 2 minus 9 in this form. We can factor x to the 2 minus 9 in this form. Using the difference of a squares identity, we can write x to the 2 minus 9 in the form of x minus 3 times by x plus 3. Let me remind you this important identity that we need a lot in this video. A to the 2 minus b to the 2 is a minus b times a plus b. Based on this identity, we can factor x to the 2 minus 9, which is basically x to the 2 minus 3 to the 2, because 9 is 3 to the 2. We can factor x to the 2 minus 3 to the 2 in the form of x minus 3 times by x plus 3. So first we try to factor numerator and denominator before multiplying numerator by numerator or denominator by denominator. Look at this numerator. We have 2x plus 6. Immediately we notice that we can factor 2 as the greatest common factor between 2x and 6. If we factor 2 from 2x plus 6, then we have x plus 3. Attention, if we multiply 2 in the bracket, we have 2x. 2 times 3 is 6. We have same expression. And in the denominator, just we have a simple term, 4x, so we leave 4x in the denominator. Now attention, when we multiply numerator by numerator, all of this is the numerator and all of this part is the denominator. Before multiplying numerator by numerator or denominator by denominator, we look for common terms between numerator and denominator, and we can cancel the common factors. If you attention, x plus 3 with x plus 3 are the common factors between numerator and denominator, so we can cancel these common factors. If you attention, we have x, which we can cancel with this x here. What remains in numerator? 6 times 2, which is 12. But we have a 4 in denominator. So if we multiply numerator by numerator, 6 times 2 is 12. This 12 simplifies by 4. 12 divided by 4 is 3. So we have a 3 in numerator. And from denominator, so we have a 3 in numerator. And from denominator, we have only x minus 3, this factor. And this is the answer of multiplying these two rational expressions by each other. Let me explain what happened to the numbers here again. This 6 times by 2 is 12. 12 divided by 4 is 3, and that 3 remains in numerator. So we write 3 in numerator. And from denominator, the only thing that is left is this x minus 3 that we wrote in the denominator. So as you can see in this example, the most important thing for multiplying or dividing rational expressions is to be able to factor numerator and denominator before multiplying or dividing the expressions. So you should be good at factoring expressions. Now look at this example. Here we have a little more complicated example. Please pay attention. Here we have a quadratic expression, x to the 2 plus 2x minus 3, or a trinomial. Let me show you first how we can factor this trinomial in numerator. We put two brackets. We put 1x in each bracket. X times x is x to the 2. Now, as you know, we try to find two numbers that their product is negative 3 and their sum is 2. Two numbers that their product is negative 3 and their sum is 2. Those numbers are 3 and negative 1. Because 3 times negative 1 is 3. is negative 3. And 3 plus negative 1 is 2. So this is the factored form for the first numerator of the first rational expression. So we have x plus 3 times x minus 1. What about the denominator? We have x to the 2 minus 8x plus 16. Let's see, can we factor this or not? We put two brackets, x in each bracket. Now we look for two numbers that their product is 16 and their sum is negative 8. Those numbers are negative 4 and negative 4. Negative 4 times negative 4 is 16. Negative 4 plus negative 4 is negative 8. This is the factored form for this expression. So the denominator can be written as x minus 4 times x minus 4. Now let's move to here. In the denominator, simply we have x minus 1, nothing to be factored. But if we look at the numerator, between 3x and 12, we can factor a common factor. What is the common factor between 3x and 12? Yes, it is just 3. So we have 3 times by x minus 4. If we factor 3 from these two there, 3 from here cancels, we have x. And if we divide 12 by 3, it would be 4. When you factor a common factor, it's like dividing every single term by that factor. So because we factored 3, 12 becomes 4. Now, again, similar to the previous question, look for common factor between numerator and denominator and cancel common factors. X minus 1 with x minus 1 cancels. X minus 4 with x minus 4. Is anything left here? No. So in numerator we have x plus 3 times 3, but it's better to put the 3 here. You can put 3 here, but it's not good way to write the answer, so we prefer to put the numbers before the brackets. And from denominator we are only left with x minus 4. And attention, for x minus 4, there is no reason to put bracket for this. For numerator, we have to put bracket for this because we want to multiply all of this by 3. But in denominator, we have just x minus 4. And because it's the only factor of the denominator, you don't need to put any bracket for x minus 4 in the denominator. And this is the answer of this question. Here we have an example of dividing two rational expressions. When you want to divide a rational expression, let's say a over b, if you want to divide it by c over d, you have to basically write the first rational expression and then multiply it by reciprocal, or basically you have to invert the second rational expression. So you have to multiply it by d over c. You have to change the numerator with the denominator. So for dividing two rational expressions, we multiply by the invert of the second rational expression. So here, to divide this by that, basically we have to write x minus 4 over x to the 2 minus 4. We have to multiply this by the invert of the second rational expression. So x to the 2 plus 5x plus 6 in numerator and x2 minus 3x minus 4 in denominator. Now this is a multiplication of two rational expressions, and basically we have to try to factor. We have x minus 4. In denominator we have x to the 2 minus 4. You know that x to the 2 minus 4 is x minus 2 times x plus 2. Here we need this identity. A to the 2 minus b to the 2 is a minus b times a plus b. So x to the 2 minus 4, which is 2 to the 2, because 4 is 2 to the 2, can be written as x minus 2 times x plus 2, based on this important identity. Now look at the second fraction. In numerator we have a trinomial, and for factoring that we put two brackets, x, Now look for two numbers that their product is 6. Their sum is 5. Those numbers are 2 and 3, because 2 times 3 is 6, 2 plus 3 is 5. What about the denominator? X. Now we look for two numbers that their product is -4 and their sum is -3. One of the numbers is positive, the other one is negative, because the product is -4. So those numbers are -4 plus 1. -4 times 1 is -4. -4 plus 1 is -3. If you want to learn more about factoring trinomials and other expressions, please watch my video. I have a full video for factoring expressions, because basically multiplying or dividing rational expressions is mostly factoring. If you are good at factoring, then this is really easy. Now back to the question. We look for common factor between numerator and denominator. If you pay attention, in numerator we have x minus 4, and in denominator also we have x minus 4. We have x plus 2, x plus 2. These cancel. Is there anything else common between numerator and denominator? No, there is no other common factor. So the final answer is x plus 3 over x minus 2 times x plus 1. This is the final answer of this question. Now look at this example. X plus 3 over 4x to the 2 minus 9. X plus 3 over 4x to the 2 minus 9. Pay attention that you can factor this in this way. 4x to the 2 can be written as 2x minus 3 times 2x plus 3. Again, here we use this identity. A to the 2 minus b to the 2 is a minus b times a plus b. Attention, how we use this identity for factoring this. This is like a to the 2 and this is like b to the 2. From 9, we take a square root of 9. A square root of 9 is 3, and we put 3 and -3 in these brackets. What is a square root of 4x to the 2? A square root of 4x to the 2 is 2x, because a square root of 4 is 2, a square root of x to the 2 is x. We suppose x to be positive, and so a square root of 4x to the 2 is 2x. So we have 2x minus 3, 2x plus 3. So this is the factored form of 4x to the 2 minus 9. So we have 2x minus 3, 2x plus 3. And now we have to divide this by this rational expression. But we know that to divide two rational expression, we can change division to multiplication, but we have to invert this, which means that we have to write this in the numerator and we have to write this in the denominator. So we change division to multiplication. So we have to factor this, and we have to write the factored form of this in the denominator. What is the factored form of x to the 2 plus 7x plus 12? The factored form of that is x plus 3 times x plus 4, because 3 times 4 is 12, 3 plus 4 is 7. And we have to factor this, and we have to write the factored form of this in the numerator. So we want to factor 2x to the 2 plus 7x minus 15. Please pay attention. This is a little hard to factor, because this is the first example that we have a trinomial that the leading coefficient, this coefficient is not 1. Here the leading coefficient is 1, so factoring this is not so hard. But factoring this, because the leading coefficient is other than 1, is a little different. Now let me show you how we can factor a trinomial when the leading coefficient is not 1. For factoring these type of trinomials, always we multiply this number, this leading coefficient, by the constant 2 times negative 15 is negative 30. So we multiply this leading coefficient by this number and we write it here. Now we look for two numbers that their product is negative 30 and their sum is this 7. So when the leading coefficient is not 1, multiply it by this number. Then we look for two numbers that their product is this and their sum is this. Two numbers that their product is negative 30 and their sum is 7. One of the numbers is positive, the other one is negative. And because the sum is 7 is positive, so the bigger number is positive. 30 times negative 1 is negative 30, but the sum is not 7 because 30 plus negative 1 is 29. So this is not the number that we look for. What about negative 2 times 15? Negative 2 times 15 is negative 30, but negative 2 plus 15 is 13, so no. What about negative 3 times 10? Negative 3 times 10 is negative 30. Negative 3 plus 10 is 7. So these are the numbers that we are looking for. Negative 3 and 10. But the way that we want to use these numbers is a little different than before. So we are not going to write two brackets here and the x and negative 3, 10. No. The way that we want to use these numbers is a little different. We start writing the expression again, 2x to the 2. Now we split 7x in this form. We write 7x in the form of negative 3x plus 10x. Where this comes from? From these numbers. We got negative 3 and 10. So we write 7x in the form of negative 3x plus 10x. Attention, negative 3x plus 10x is exactly 7x. This is the way that we use these numbers. And minus 15. Now we consider these two first terms a group and we factor the common factor between them, and we consider these two as another group. What is common between 2x to the 2 and minus 3x? X. So we factor x from these two and then we have 2x minus 3. Between 10x and negative 15, 5 is common, so we factor 5 and then we have 2x minus 3. Now if you pay attention, between this term and this term, 2x minus 3 is the common factor. So we factor 2x minus 3 and then we have x plus 5. By factoring this, from the first term we have x, from the other term we have 5. This is the factored form of this trinomial. So in numerator we write 2x minus 3 times x plus 5. Attention, the reason that we write the factored form of this in the numerator, because attention, this was division. In division, we have to multiply by the inverse of the rational expression. That's the reason we write the factored form of this in the numerator. Now look at the numerator and denominator and try to find common factors to cancel. X plus 3 with x plus 3 cancels. 2x minus 3 with 2x minus 3 cancels. And there is nothing else to cancel. So the final answer is x plus 5 over 2x plus 3 times x plus 4. Now look at this example. We have a compound rational expression. We have a fraction, a rational expression in numerator divided by another rational expression. So this is like a division. If you want, you can write this in the form of x3 over x plus 2 divided by x over x to the 2 plus 6x plus 8. But we know that when we have division, we write the first fraction, the first rational expression, we multiply by the inverse of the second rational expression. So x to the 2 plus 6x plus 8 goes to numerator and x goes to the denominator. Now, attention that we can factor this trinomial here easily. We can factor it as x plus 2 times x plus 4, because 2 times 4 is 8, 2 plus 4 is 6. This is the factored form of that trinomial, and we have x in the denominator. Now look for common factors. This cancels with this, and x to the 3 with 1x cancels here, and we have x to the 2 in the numerator, because x to the 3 is x times x times x. 1x with 1x cancels, and 2x in numerator remains, which we multiply by each other. X to the 2 remains in the numerator. So finally, what remains from denominator? Nothing, basically 1. And in numerator, we have x2 times x plus 4. So the final answer is x2 times x plus 4. Here we have an example of multiplying two rational expressions, but we have two variables in the rational expressions, x and y. So again, as usual, we have to try to factor the expressions. It should be clear that we can factor x to the 2 minus y to the 2 in the form of x minus y times by x plus y. We can factor this in the form of x minus y times by x plus y. What about the numerator? For numerator, please pay attention. For x to the 2 plus 2xy plus y to the 2, because we have the variable y, maybe at first this is a little confusing how we can factor this trinomial. But if you consider this as a normal trinomial, like x to the 2 plus 2x plus a number, how we factor a trinomial like this? We put two brackets, and in each bracket we put x. Do the same thing for here. So whenever we have the extra variable y, for factoring trinomials like this, we behave it like the normal trinomial. So we open two brackets, in each bracket we put x, because x times x is x to the 2. Now, please pay attention. We look for two terms that their sum is 2y and their product is y to the 2. What are the two, not numbers this time, what are the two terms that their product is y to the 2 and their sum is 2y? Those terms are y and y, because y times y is y to the power of 2, and y plus y is 2y. Attention, coefficient of x here is 2 times y. These two are the coefficient of y. So y plus y is exactly 2y. So this is the factored form for x to the 2 plus 2xy plus y to the 2. And you can check this by multiplying these two brackets by each other. So the factored form of the numerator is x plus y times x plus y. Now, what about the denominator? What is the factored form of x to the 2 minus xy minus 2y to the 2? Again, we put two brackets, x in each bracket, because x times x is x to the 2. Now we are looking for two terms that their product is negative 2y to the 2 and their sum is negative y. Forget x, x is here. So we are looking for two terms that their product is this and their sum is negative y. The two terms have y, so both of these brackets, both of these terms basically that we are looking for have y, but with a number like 2y, 3y, negative 2y, something like that. Two things are multiplied by each other and we have negative 2y to the 2. Focus on the negative 2. What are the two numbers? You can think it this way, maybe it's easier. What are the two numbers that their product is negative 2? Two numbers that their product is negative 2 can be negative 2 times 1 or negative 1 times 2. But between these two pairs, we are looking for the one that the sum is negative. Negative 2 plus 1 is negative, but negative 1 plus 2 is positive. So this is not the answer that we look for. So the numbers, the things, the term that we are looking for are negative 2y, negative 2y plus 1y or y. And this is the factored form of this expression. Let me show you an extra example here that can help you to understand what's going on here. Suppose we want to factor x to the 2 minus 2xy minus 8y to the 2. Here what we have to do, we put 2x here, then we look for two terms that their product is negative 8y to the 2. Focus on negative 8. What are the numbers that their product is negative 8? The numbers that their product is negative 8 can be negative 1 times 8 or negative 8 times 1, or it can be negative 2 times 4 or negative 4 times 2. But between all of these pairs, which one is the answer? We are looking for the one that their sum is negative 2. So this is not the answer, this is not the answer. Negative 2 plus 4 is positive 2, no. So this is the thing that we look for. So what we have to write here? Negative 4y and the other one plus 2y. This is the factored form of this. X minus 4y times x plus 2y, because we got negative 4 and 2. So as you can see, when we have extra variable y, the technique for factoring is the same. But the difference is that you have to add y to the second terms. So the factored form finally for denominator is x minus 2y times x plus y. Finally, for the numerator, what is the factored form of this? Here the story is a little harder because as you can see we have a leading coefficient other than 1. We have a 2 here. So if you remember from previous example, when we have a leading coefficient other than 1, what we do with this? We multiply this number by whatever is here. So for factoring this, we multiply this 2 by this. 2 times negative y to the 2 is negative 2y to the 2. Now we look for two numbers. Forget y, focus on the number. We are looking for two numbers that their product is negative 2 and their sum is negative 1. What are those numbers? Two numbers that their product is negative 2 and their sum is negative 1. Those numbers are negative 2 and 1 because their product is negative 2 and the sum of these two is exactly negative 1. What we do with these numbers? If you remember from previous example that I showed you before, we write 2x to the 2. And now our job is to split this in the form of negative 2xy plus xy. Again, where this comes from, do you remember the numbers that we got was negative 2 and 1. So we write negative xy in the form of negative 2xy plus 1xy. Negative 2xy plus 1xy is again negative xy. Again, please attention, if you want to learn more about factoring, watch my video. I have a full video for this topic and you can learn all the techniques of factoring in that video. Now what we do? we consider these two as a group, and we consider these two as a group. We factor common factors. From the first two, we have 2x times x minus y. From the next two, we can factor y, then we have x minus y as well. Now, this equals to x minus y times 2x plus y. So this is the factored form of that. So in numerator, we have x minus y times 2x plus y. Now let's see what are the common factors to cancel. X plus y with x plus y cancels. X minus y with x minus y. Is there any other? Yes. X plus y with x plus y cancels. So what remains from numerator? From numerator we have only 2x plus y, and from denominator we have x minus 2y. This is the final answer for this question. Look at these examples. They seem pretty easy, but maybe they are also a little maybe tricky. We have x over y divided by z. So you have to attention that this is like x over y divided by z. But we know that when we divide by something, we have to multiply it. We have to multiply this by inverse of z, or reciprocal of z, which is 1 over z. So it's like this. And finally the answer is multiply numerator by numerator, denominator by denominator. Here we don't have anything to simplify. That's the reason immediately we multiply numerator by numerator, denominator by denominator. And this is the final answer for this. What about the other one? Here the story is different. X is divided by y over z. Attention, when we have a fraction, fraction is a division. Whenever in math you say 2/5, it's like 2 divided by 5. Remember, this is the meaning of a fraction or rational expression. Rational expression is basically numerator divided by denominator. So x over y over z is x divided by y over z. We know that in dividing we multiply by inverse of the second rational expression. So now multiply numerator by numerator, x times z, and denominator is basically here is 1. 1 times y is y. So as you can see, the answers are different. I hope by watching this video you have learned how to multiply or divide rational expressions. If you like this video, please subscribe to my channel and see you in the next videos.